Assalamualaikum. This is Digital Logic and Circuit Final Assessment presentation. I am Mehdi Hassan Michal from section G. In this presentation, I have designed a synchronous binary irregular counter by using my ID. So I have taken the middle portion of my ID and compared it as A, B, C, D, E. I have written the flow A, B, C, D, E, A. But in my ID, there is repeat and decade. So I have added 1 with C and 2 with E. So I have got this new sequence 4, 0, 1, 3, 2, 4. In step 1, I have written the binary of the given decimal number. So for 4, the binary number is 100. For 0, the binary number is 000. That's how I have taken all the binary values. In step 2, I have identified the number of flip-flop required. As in my system, I have the maximum decimal value is 4. So the system can be repeated with 3-bit output 100. So the output of the system will be Q2, Q1, Q0. Hence, we will need 3 flip-flop in synchronized connection. So in this slide, I have designed a 3 flip-flop synchronized connection. Moving to the next step, I have designed a counter table here and filled it by the present state and the next state. In present state, I have took Q2, Q1, and Q0, same as the next state. In the present state, our first state is 4. So for 4, the decimal number is 100, and our next state is 0. So for 0, the decimal number is 000. I have took here 1 as Q2, 0 as Q1, and the last 0 as Q0. Same and the next step. That's how I have filled this whole table. In our step 4, I have written the transition table here, which is fixed for solving this kind of problem. In our step 5, I have completed it by using counter table and the transition table. So in counter table, we can see that value of Q0 is 0 in the present state. And in the next state, the value of Q0 is equal to 0. So 0 to 0. So from this transition table, we can see 0 to 0, the value of J is 0. And the value of K is don't care. So 0 to 0, here 0 to 0, the value of J0 is 0. And the value of K0 is equal to don't care. So I have put it like this. And I have filled the whole table by using the same system. Moving to our next step. Our next step is to fill up K-maps for J0, K0, J1, K1, and J2, K2. So I'm explaining one K-map, which is J0 map. In this map, we are putting values from our step 3. In step 3, we can see that value of 100 and or 4 is J0 value is 0. And for 0, 0, 0, 0, the value of J0 is 1. These are the all values for J0. So we're going to putting them into our J0 map. So for 100, the value is 0. And for 000, the value is 1. But we are only getting 5 values from that table. So what will be the other values? In other shell, we will fill it with don't care. I have marked them as red. So in this map, I have grouped 1 and a don't care. So the SOP expression of J0 will be as in Q0, 0 and 1 cancelling each other, and the value of Q2 is 0, so Q2 bar, and Q1 is 0 also, so Q1 bar. That's how I filled all the maps. I have got 6 maps because I have got 3 flip-flops. In K2 map, we can see all the values are in a group. So what will be the output of the K2? The output will be 1. So in this slide, I have summed up all the final output connections. By using them, we will fulfill our final and step 7. In step 7, I have drawn a diagram by connecting the output connections. So from this one, we can see J naught is equal to Q2 bar and Q1 bar. So here we are taking Q naught bar right below the Q naught, and Q1 bar right below the Q1, and Q2 bar right below Q2. So Q2 bar is coming from here, and Q1 bar is coming from here, and both are added by AND gate, and this is the output of J naught. That's how I have designed the whole diagram. As for K1 is equal to 1, so K1 is equal to height 1. I have written like this. So that's how it designed a synchronous irregular counter. That's all from me. Thank you so much.